Okay, so just to finish this off, the problem with having this number box to determine which of those we are choosing between is that it's not very descriptive. We know that 0 is off, but 1 or 2, and if we had more oscillators again, so we had a square and a triangle, for example, then 3 and 4 for square and triangle respectively, not very descriptive. So we might want to be able to label them in a slightly more meaningful way, and to do that we're going to use what's called the uMenu object. So here we will find that down, where is it? Here, uMenu, but you can also obviously make an object and just put uMenu into it. Connect that to the left-hand outlet to the selector object. And what uMenu does is it takes a variety of labels that you can put into it and will output a number for each of those labels. So what we'll do is we will, in order to, obviously it's blank at the moment, so we need to put some names into it. And you do that in the inspector window. So we go into there and find, right at the bottom, menu items. So edit that. And we will put in off, comma, and it's the comma that separates the menu items. So for every menu item you need to separate it with a comma. Each menu item can obviously be more than one word, but it needs to be, the items themselves must be separated by commas. So we'll put in off sine, which obviously is more intuitive anyway than cycle, because we don't know what type of wave cycle is necessarily. Saw. Well, that will accommodate the 2 oscillators that we currently have, but we might want to add a couple more. So we will put in a triangle, triangle and a square wave. That will do for now. And when I OK that, those names appear in here, and we also see that something pops up here, the off, the first item in our list pops up there. So we've kind of finished with the uMenu inspector for the moment, and I'll close that. And now when I lock the patch and I click on the menu, then it offers me a drop-down menu with all the items in that I put in. And it so happens that each of those items is allocated a number. And those are consecutive. So off will be given a 0 message, sine a 1, saw a 2, triangle a 3, and square a 4. And I can prove that if I send from the left-hand outlet a number into a number box. So off sends a 0, sine sends a 1, saw sends a 2, and so on. So we're using those numbers to communicate with selector, and then of course so triangle, the message triangle is not being sent to selector, it's the number that's associated with that message that is being sent to selector, which of course recognises it as an inlet to accept data from. So that's basically it for the uMenu, except of course that we now have to add 2 oscillators to make up our list. And so I'll do that by making these 2 objects. Try. Okay, so unlike what I've put in the exercises 5a, you could give it a 0.5 argument, but you don't actually need to. What the argument will do is control what's called its duty cycle, which is where it's going to be difficult to explain this without sort of gesticulating, but if you imagine that a triangle wave is supposed to be that shape, if you follow my cursor, actually what I'll do is I'll make a function object because that makes it clearer. There we are. Function. There we go. If you imagine that a triangle wave is supposed to look like something like that, with then you can imagine that the point of its triangle is at 0.5, which is why I've asked you to put the 0.5 argument there. But if you put a different value for its duty cycle, then you might make it 0, which would give you a a sawtooth wave in one direction. If you put it at 1, you'd have it here, which gives it a sawtooth in a different direction, if you see what I mean. And so 0.75, sorry, we'll put it somewhere there. 0.25 will put it there. So you can see that the shape of the wave will change depending on what value you put in. But by default, it seems that it actually goes to 0.5 anyway, so you don't necessarily need to put an argument in, but if you do, then that's fine. So we'll use that, and we will also use a rect, which gives us a square wave, or can do. This also has a duty cycle, and in this instance, oh dear, I need my function object again. It determines where the well, you can't quite make a proper square wave here, but we can make something akin to it. Whoops! Oh dear, go away. There. So this, once again, you can put in a value between 0 and 1, and 0.5, which is approximately where this is, will determine this as being a square wave. If you had it at 0.25, for example, then it shifts that the point at which you move from a value of 1 to a value of -1 in terms of your wave shape to 0.25 or 25% through that waveform, if that makes sense. So what you can do in that instance is to make a pulse train of pulses of different lengths, but a pulse train which has pulses of equal length, i.e. -1 and -1 and -1 being equal lengths, will be a square wave. So that's how that works, and in this instance I do believe you do need to put in 0.5, but I may be wrong about that. Anyway, it doesn't matter too much. So I can send that to there, and sorry about the clutter. If I add another couple of inlets to my selector object, so 4, and connect those, then we have our available oscillators, and we can choose between them. So let's see, is that going to give me, oh hang on, I need to choose that. There we go. So that's a sine. We can choose a saw. We can choose a triangle. And we can choose a square. So we have a variety of different wave shapes, and we can choose between them.